So in this video, I want to prove that the product of three consecutive positive integers is a multiple of 6. Now, if we go along the lines of the proofs that we've already seen, what we might end up trying is saying something like, let k be a positive integer, and then we could say that k plus 1, k plus 2 are three consecutive positive integers, which seems reasonable. So then, because we're looking at the product, we would multiply these three together. Now, if I leave the k alone, we'll multiply those two together. So we're going to get k squared plus 3k plus 2, expanding out those double brackets. And then you can multiply through by k. We get k cubed plus 3k squared plus 2k. Now, when you get to this stage, you look at it and go, well, I can't factor out 6 here. In fact, I can only factor out k, and I've already got that in that previous line. So at this stage, you get a bit stumped. The algebraic method that I've shown you kind of breaks down here. So really, this proof is a lesson in that the algebraic method, there may not be necessarily a way of doing it very easily. So, okay, so how do we do it then? How do we prove this? So we pick ourselves back up and go, right, is there another way of explaining it? So, if I've got three consecutive positive integers, let's look at some, just to start off with. Let's say we've got 1 times 2 times 3. Well, of course, that's 6. And that's a multiple of 6, so we're all good. 2 times 3 times 4. So what's that, 24? Okay, that's a multiple of 6. And 3 times 4 times 5. That's 60. That's a multiple of 6. What about 4 times 5 times 6? That's 120. Let's go one more. 5 times 6 times 7. 6 sevens are 42. Or 5 sixes are 30. So 30 times 7 would be 210, wouldn't it? 6 sevens are 42 times 5 is 210 as well. Okay? And so on. So, and all of these are multiples of 6. Okay? So I'm going through 5 examples. I'm relatively convinced. Okay? Now, the key here to being able to do this proof is looking at the structure of these three numbers as you work your way through. The first thing to identify is that you will always have either two odd numbers and an even, so odd, even, odd, odd, even, odd, odd, even, odd, or even, odd, even, odd, even. So we either have even times odd times even, okay, which of course is even, or we've got odd times even times odd, which is also even. Because you've got an even factor in there, the whole thing has to be even, because you could factor out 2. So regardless, you're always going to get an even value. If the result is always even, therefore, it must have a factor of 2 okay, because it's even. Right, what else do we notice? Well, notice that in each of these, you're always going to pick up a multiple of 3. You've got 3, then 3, then 3, then 6, then 6, then 6, then it'll be 9, 9, 9, 12, 12, 12. So whenever you're looking at your 3 integers, okay, and you're multiplying together 3 consecutive integers, you'll always pick up a number that's in the 3 times table. So because we are selecting 3 consecutive integers, or positive integers, one of the 3 will be a multiple of 3. So one of the numbers of your 3 will always be a multiple of 3. 3, 6, 9, 12, etc. So it must have a factor of 3. If one of your 3 numbers is a multiple of 3, then the whole thing has to have a factor of 3. If it has both a factor of 2 and a factor of 3, as it has a factor of 2 and a factor of 3, then 6 must be a factor, because 2 times 3 is 6. So it must be a multiple of 6. And that concludes my proof. Okay, so it's very much a 3-pronged attack here. The first stage must be identifying that it has a factor of 2. Then we identify it has to have a factor of 3. And then the conclusion is that if it has both of those, it must have a factor of 6. And so the number must be a multiple of 6. Okay? This proof comes back again at A level. It's one that we look at there as well. So it's well worth your time knowing this proof now.